Welcome to Approximating Limits. So as we saw in our intro to limits video, we have a couple ways that we can go about sort of approximating what a limit is. So we have two ways, maybe more. We can approximate limits. Option one was by looking at a graph. And in doing this, we essentially just traced the graph to see what what the y value was looking like as x got close to our value. And then option two was numerically plug in x values close to our target x value and see what happens. So we're going to practice our limit notation here. So this first example, we want to approximate. We have lim, and then we have x with an arrow going to 2 and f of x. So this is the limit of f of x as x approaches 2. So we were supposed to approximate the limit of f of x as x approaches 2 for the function f graphed below. So let's go ahead and take a look at this function. So we're targeting as x approaches 2. So that's down here. So that means that we are looking at as x approaches 2. And then we are just going to trace along the graph and see what happens as we get close to x equals 2. So here we're tracing along the graph and we're getting close to x equals 2. And that looks like we're at about y equals 4. And if we do the same thing from the right, again, tracing along the graph, x is getting closer and closer and closer to 2. And once again, it looks like we are going to a y value of 4. So we would say that the limit as x approaches 2 of f of x, or the limit of f of x as x approaches 2, appears to be 4, or is approximately 4. So that's following the graph. Now here we're going to do one where we instead just plug in values. Again, we could also use a graphing calculator and just graph it and see what happens. So what we are looking for here, we're looking at the limit of that rational function as x approaches 1. So we are looking for the limit of x squared minus 3x plus 2 over x squared minus 1 as x approaches 1. So I can tell you right now that we can't simply just plug in x equals 1. you can see that denominator would wind up being 1 minus 1 or 0. And we can't divide by 0. So we absolutely cannot simply plug in x equals 1. We'll go ahead and do our t-table. So we'll have x and f of x. And let's go ahead and just start with 0.9, and then 0.99, and 0.999. And then we'll come in from the top or from above. So let's do at 1.1, and then 1.01, and 1.001 as we get close to x equals 1. So if we plug these in, I'm not going to do this one off the top of my head. I'm going to go over to an online calculator called Desmos and do the work there. All right, so I'm in a program called Desmos. And unfortunately, if you use X, then it'll just do the graph and you can't put in specific X values. So I'm using C instead of X. So I've put in C equals 0.9, and then I've typed in the function again using C instead of X. So we wound up getting that when you plug in 0.9 out, you get about negative 0.57, which I'm just going to jot down, or negative 0.579 approximately. Now, if we change that C to 0.99, then we are now at negative 0.507 or negative 0.508 for our Y value. And if we make that 0.999, we wind up at negative 0.501 approximately. And then if we come in from the right, starting at 1.1, we are looking at negative 0.428 or negative 0.429. If we do 1.1, we are now looking at negative 0.422 if we round, and if we do, oops, sorry, that shouldn't be that. That should be 1.01, which would be negative 0.492 or 493. And then if we do 1.001, we are now looking at negative 0.499. So if we switch back to our notes where I've recorded these values, then we can see that as our X values get close to 1, it looks like we're getting to negative 0.5 for Y. So we have f of x is going to negative 0.5 as x is getting close to 1. And so our statement would be that the limit as x approaches 1 of this f of x, or of x squared minus 3x plus 2 over x squared minus 1 is, we are approximating it to be negative 0.5. So this is how we can go about just approximating limits, either by looking at a graph or by just evaluating what is happening close to that x value.